Order of operations and fractions. The simplest way to work with fractions is to imagine that the numerator and the denominator are each in their own set of parentheses. Before you divide the numerator by the denominator, you must have them both in simplest form, and then you must be very careful about what you can do with them. For instance, a common error is shown below. So here we have the expression of x over the quantity of 1 plus x. So I cannot divide the top and bottom by x to get 1 divided by 1 plus 1. Rather, I have to think of the denominator of 1 plus x as being inside parentheses. And until I can simplify that further, which right now, again, we cannot, this is the simplest form. Again, x over 1 over x cannot simplify further. We cannot change it to anything else. It has to stay x over 1 plus x. So here's an example of how you would evaluate an expression that's a fraction. Here we have 4 times 3 minus 3 squared divided by 5 plus 6 divided by 2 plus the quantity of 5 minus 8 all over or divided by 7 minus 8. So how would you evaluate this expression? Think of your order of operations. Think of the fact that now we have to treat the numerator and denominator separately. We have to simplify them first before we can divide. So in order to do that, first we're going to recognize the terms in the denominator act like they are in parentheses, and again the numerator. So we're going to simplify that first. We're literally putting, like in this step here, we're literally putting the parentheses around the 7 minus 8. So we want to do the parentheses or all the operations in that parentheses first, and then keep the results in parentheses until the next operation. So here we're doing 7 minus 8 is negative 1. So that's what we get in the denominator. That's what's changing from here to here. And we're also in the numerator, we already had a set of parentheses. We had our 5 minus 8. So we're also changing that in the numerator to a negative 3. So we're taking care of all those parentheses, that's the operations inside them first. We are doing parentheses first because we're thinking of, again, that acronym of PEMDAS, and P is first. Then we come to E for the exponents and the roots, which we did have here, 3 squared. We're going to change to a 9, 3 times 3. So we're taking care of that for the P and E and PEMDAS. Now we can move on to the multiplication and division, because after the P and the E come the M and the D. And they happen at the same time within an expression. You read, though, from left to right. So you want to do whatever comes first, reading from left to right. In the denominator, there is no multiplication or division. You just have a negative 1. But we do have in the numerator. So we have 4 times 3 is all the way to the left. So first we're changing that to a 12. Then we have 9 divided by 5. So that gives us 1.8. Then we have 6 divided by 2. And that gives us 3. So again, I read from left to right. I did this first, and I did this second, and I did this third because I read from left to right. So that takes care of all the multiplication and division, so that finally we can move on to our last step of the addition and subtraction, reading again from left to right. So here we're going to do 12 minus 1.8 first. So that is going to give us 10.2. So then we still have plus 3. So that will give us, I'm going to come over here, do some side work. So 10.2 plus 3 is going to be 13.2. And then plus a negative 3, which is really 13.2 minus 3, which is going to give us 10.2. So that is our numerator after we've simplified all the multiplication and division and the addition and the subtraction. So now we've completely simplified the numerator. The denominator was already completely simplified with that first step of changing it to a negative 1. So now we have permission to divide the numerator by denominator. So dividing 10.2 divided by negative 1 gives us a final answer of negative 10.2. So again, you have to be careful with fractions. You have to treat the numerator separately from the denominator and simplify them both individually, completely simplified before you can divide the numerator by denominator. This has to be The very last step.